The second stoichiometry problem is a moles to mass conversion, where you are given the moles of one substance and you want to convert that to mass of another substance. So what we do is, when I give you moles of one substance, to convert to mass, you need to pass through the moles of the other substance before converting to mass. Let's see how it works. In this example, suppose we start with 2.34 mole of octane. How many grams of water will be produced? So here you are given the molar mass of water as 18.02 grams. So we are using a similar equation, the equation we can see here, to help us in solving this problem. So how do we approach this problem? What are we asked to determine? Here we see that we are given 2.34 mole of octane, but we want to determine the grams of water. This is what we want to do. So the first thing we are going to do is to connect the two. Moles of octane, and here the water. How do we connect these? If you are given moles of octane, you need to also obtain the moles of water. So what you are going to do here is to try to determine the mole of water. After obtaining the mole of water, then you will determine the mass of water. So you don't want to just jump from moles of octane all the way to mass of octane. You need to determine the moles of water first before obtaining the mass of water, because once we know the moles of water, we can easily determine the mass of water. So based on this observation, we can see that we have two conversion factors. Conversion factor 1 is going to give us moles of water from the moles of octane. Conversion factor 2 here is going to give us mass of water from the moles of water. And then, as usual, we'll have our given quantity, which is 2.34 mole of octane. So let's see how it works. So first, you are given the moles of reactant. This is our reactant. And you need to determine the moles of the product. This is our product. And then you are going to get the mass of the product. This is what we are saying here, spanning through two conversion factors. So as usual, we start with our given quantity, which is 2.34 mole of octane. That's what we start with. Alright, so what is the conversion factor that we are going to put as our first conversion factor? Now, for you to determine the conversion factor you are going to put, you need to know that the conversion factor must cancel this one. The conversion factor must cancel the mole CHH8, which means down here you need to have mole CHH18. So in this case, you are moving from the moles of octane to the moles of water. So if you have moles of octane here, you need to have moles of water at the top. So this is what you are doing, and you see that this moles of octane is going to cancel with the moles of octane up here. That's how you do your conversion. So here we are moving from moles of octane to moles of water. So at the top here we need moles of water. That is the first conversion that we are going to make. What about the second one? So here I am just giving you the conversion without numbers. I will think about numbers later. What about the second conversion? So the second conversion should have water down here because you want to cancel the mole of water here. So I'm gonna have the mole of water down here. But what are we doing? We are moving from moles of water to mass of water. So that means if I have moles of water here, I need to have the molar mass of water up here, so that in the end I obtain the mass of water that I'm looking for. So down here we need to have moles of water because we want these moles of water to cancel with these moles of water, so that in the end what we are remaining with is just the mass of water. Every other unit has cancelled. So this should be our answer, the grams of water. So what about the numbers that we put there? Here we know that there's 16 there is 18 water here, and there is 2 octane here. 2 into 18, we are going to have 9 here and 1 here. This one is telling us the number of moles. Each 1 mole of water has the molar mass up here. So here you should always have a 1 down here when you compare it to the molar mass up here. So in terms of the solution, we see that 2.34 mole of this times 1 mole of this times 9 mole of water divided by 1 mole of octane, because the moles of are going to cancel, the moles of octane are going to cancel, and then the moles of water also are going to cancel. 18.02 grams per mole, that is the molar mass of water. That's why we put 1 here and we put 18.02 grams water there. So in the end we get 380 point grams of water. The point is just telling us the number of significant figures. So this answer has 3 significant figures. But just to repeat, it is important to cancel the units. If you know how to cancel the units, it will be easy to determine the conversion factors that you want to have for a problem like this one. Thank you.